Hi class. We are looking at lesson 8.5 today, comparing transformations. We've been looking at the 4 transformations for the past couple weeks, translations, reflections, rotations, and dilations. And now this lesson is about seeing if you can identify the transformations that are occurring. Because sometimes you can move things with more than one transformation. And so we're going to explore that today. We are on page 50 in our workbooks. And let's go ahead and get started. I'm going to pull this back. Last video, the last video, it was not showing enough of the page. So hopefully this will. All right, let's look at number 1, a triangle with coordinates A, 3, 1, B, 4, 0, and 5, and C, 5, 3 is drawn on the coordinate plane. 4 other triangles are the images of triangle ABC after each of the transformations in A to D. So A says triangle ABC is mapped onto triangle DEF by a translation of 6 units to the left. Draw DEF. Okay, so we need to take this and we are just moving it 6 units to the left. So we're going to move each point 6 units. 2, 3, 4, 5, 6. Now instead of A prime, they tell us to call it D. A is now called D. B will be called E. 6 units to the left. That's 4, 5, 6. This is E. And then F is where C is 6 units to the left. So this is 5 units, and then one more makes 6. And that is C. All right. Oh, not C. F. All right, D, E, F. So D connects to E. E to F. F. All right, so we have taken this and translated it 6 units to the left. B says ABC is mapped onto GHI by a reflection about the x-axis. Draw GHI. Okay, so instead of A, we're going to put G. Instead of B, we're going to put H. And instead of C, we'll put I. All right, so it is a reflection. This is our x-axis. B is on the x-axis, so it stays on the x-axis. But A is 1 unit above, so the reflection would be 1 unit below. And they said to call that one G. So this is G. H is where B is. Well, B is already on the x-axis, so H is going to stay here. So I'm just going to write H next to B. And then C is 1, 2, 3 above the line of reflection. So I need to go 3 below. 1, 2, 3. And instead of C, we need to call that I. And then we connect them. G to H. H to I. And I back to G. All right, so there's the reflection. C says triangle ABC is mapped onto triangle PQR. So instead of A, we'll call it PQ. B is now going to be called Q, and then C will be called R. With the center O, it is mapped by a rotation of 180 degrees about the origin O. Draw J, K, L. All right, so this is our original. We're going to go 180 degrees about the origin. And it doesn't matter if you go clockwise, because you'll end up here, or counterclockwise, because you'll end up in the same place. I don't know if you remember, but a rotation what we are going to do is make the coordinates opposite. Remember, if it was 90 or 270, we switched the y and x. But if it was 180, we just take the coordinates and do the opposite. So A is going to be called J. A is at 3 and 1. Now, the opposite of 3 is -3. The opposite of 1 is -1. So J is going to be at -3, -1. So we're going to go back 3, down 1. And we need to call that J. Okay, K is B. B is at 4 and 0. The opposite of 4 is -4. 0, there is no opposite, it's just 0. So -4, 0. That's going to be K now instead of B. And this point up here is at 5 and 3. The opposite of 5 and 3 is -5, -3. So I'm going to go back 5, down 3, and this is called L. And then we connect them. J to K, K to L, L to J. All right, there is the rotation. Okay, AB is mapped onto PQR by a dilation with the center O and scale factor 2. All right, yay, the center is at the origin. So all we have to do is multiply the coordinates by 2. And so A is 3, 1. And if I multiply 3 times 2 and 1 times 2, instead of 3, 1, I'm going to have 6, 2. So I'm going to go over 6 and up 2. And instead of A, we are going to call that P. All right, B is at 4 and 0. Now we're going to multiply both by our scale factor, which is 2. Got something on my glasses. And 4 times 2 is 8, 0 times 2 is 0. So 8 and 0 is our next point. And instead of B, it tells us to call that Q. R is where C is. Let's see, C is at 5 and 3. We got to multiply 5 and 3 by 2. That would be 10 and 6. So I'm going to go over 10, up 6, which is here. And that is point R. All right, P to Q, P to R, and R to Q. All right, class, so now we've done the dilation. All right, so we did all of these. I want you to answer E and F. Looking at that, I want you to answer E and F. I think you should be able to answer those. All right, let's go to the next page, number 2. Quadrilateral PQRS with the coordinates P, -1 and 4, etc., undergoes the following transformations. PQRS is mapped onto P prime, Q prime, R prime, S prime by a reflection about the y-axis. Draw PQRS prime, and then we'll do B in a second. Let's go ahead and draw our original quadrilateral, PQRS. P is at -1, 4. So we're going to go back 1, up 4. That's P. Q is at -6, 3. So go back 6, up 3. This is Q. R is at -6 and 1, which is here. That's R. And S is at -3, 1. -3, 1. All right. And then we connect them. Did I label the last one? No, I didn't. That is S. All right. That is just a quadrilateral. Yep, it's just a quadrilateral. Okay, we've got the original. PQRS is mapped by a reflection about the y-axis. Here's the y-axis, okay? So P is 1 unit away to the left. P prime will be 1 unit away to the right. And then Q is 6 units away from the y-axis to the left. So Q prime is going to be 6 units away to the right. R is also 6 units away from the y-axis. So we're going to put R 6 units away in the other direction, R prime. And then S is 3 units away. So I'm going to do 3 units in the opposite direction. That's S prime. Okay, then we connect them. Didn't do a very good job on that one, but all right, so there is our reflection. That's P prime, Q prime, R prime, S prime. PQRS is mapped to P double prime, Q double prime, R double prime, S double prime by a reflection about the x-axis. All right, so here's our x-axis. So we need to do P double prime, etc. I'm going to just start with what's closest. R is 1 unit away from the x-axis. R double prime will be 1 unit away in the opposite direction. Q double prime is 1, 2, 3 away. So we need to make it 3 away. That's Q double prime. All right, I want you to finish the rest of it. And then answer C. C says P, Q, R, S, all that prime can be mapped to the double prime by a single transformation in 2 ways. Describe each of the 2 ways. So once you have this one here, there are 2 different motions that you can move this to here. Would it be a reflection, a rotation, a translation, or a dilation? I want you to figure out the 2 ways. All right. My battery is running low. Give me 1 second to plug it in. All right, it was not literally 1 second, but you get the idea. I would hate to lose power in the middle of this. Okay, the diagram shows 3 triangles. We're on number 3. 3 triangles, P, Q, and R in a coordinate plane. And here's P, here's triangle Q, here's R. Triangle Q can be mapped onto triangle P by a single transformation in 2 different ways. Describe each of the 2 ways. Okay, so there are 2 ways to go from P to Q. Think about it. Could we get from P to Q by a translation? That's a slide. Can we slide it over? Well, the answer is yes. So we can slide it over by a translation. Okay. And how about a reflection? Can I flip it over to that side? Well, the answer is yes, a reflection. The other 2, dilation, clearly we are not dilating because they're the same size. And we are not rotating because if you rotate it, it's going to be facing a different direction. So these are the 2 transformations that we can go from here to here. If we want to quantify it, let's see how far will we translate. This right point, this point on the right side, will move to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 units to go from here to here. So translation to the right, 10 units. Now a reflection needs a line of reflection. And this, I was looking at this ahead of time and I was trying to use Y as my line of reflection. And in that case, this point is 3 units away, but this point is 1, 2, 3, 4, 5 units away. And so this cannot be our line of reflection. But is there a line that we can make where they are equally distant apart? Well, from here to here is 8 units. So the line of reflection would be 4 units away from each. So if I move this 1, 2, 3, 4, if I put this, now if this is my line of reflection, this point is 1, 2, 3, 4 units to the right. And this point, to the left. And this point is 4 units to the right. So it is a reflection across, and what do we call this? This is a vertical line. A vertical line always starts with x equals, and it's going through -1. So it is a reflection across x equals -1. All right, B, describe the transformation that maps Q onto R. So is this a translation? Is it a reflection? Is it a rotation? Or is it a dilation? What do you think? Well, you should say the only one it could be is dilation. A dilation is the only transformation that takes a shape and makes it larger or smaller. All right, let's look at the next page. Refer to the diagram below. 4 triangles are shown on the coordinate plane. And then it says, describe the transformation that maps triangle A onto triangle B. So to get from A to B, is that a translation, rotation, reflection, or dilation? There is one transformation that will get it from here to here. And what is it? It is a rotation. It is a rotation. All right, I want you to try B, C, and D on your own. Name the transformation that goes from B to C. So how do you get from B to C? What is this? How do you get from A to C? What kind of transformation makes this happen? And how do you get from C to D? C to D. And you can just name the transformation. You don't have to quantify it with lines of reflection or how many units, just name it. All right, 5. Oh, and good news, 6, we're going to omit. So this is our last one, 5. The table shows the coordinates for the vertices of 4 triangles. So triangle P has these coordinates, triangle Q has these coordinates, R has these coordinates, and S has these coordinates. All right, so you're going to draw these 4 triangles. I want you to draw them on here. And then I would do kind of what they did on these. Instead of naming the points, just write the name of the triangle. So wherever P is, write P in the middle of it, or Q, or whatever. So use these coordinates, draw the triangle, but then write the name of the triangle. I think that would be easier than writing A, B, C, A prime, B prime, C prime, etc. And then you're going to describe 2 single transformations that map triangle P onto Q. So you're going to look at P and Q and decide what are 2 ways that it can get from P to Q. And then C, describe a transformation, that's only one, that maps Q onto R. And then D, the last one, says describe a transformation that maps R onto S. And I just need the name of the transformation. I do not need you to quantify it. All right, class, that is just kind of putting it all together. That concludes our Unit 8 on transformations. You guys have a great day and contact me if you need help or have questions. Have a great day.